certification. And the only reason why we haven't got it is just we hadn't actually have time. So me, Hoyt, and Nancy, and Allison, and Hoyt might run into when you go into the maintenance field, especially if you have to do any type of adjustments or stuff like that, like setting the heights of the sensors and stuff like that, you might have to use some of these. Learn how to calibrate your instrument, carry maintenance of an instrument, advanced diagnostic sessions, and I have no idea what they is. So why are these called instruments? Of course, anything that we use to supplement or make measurements or display or stuff like that, we call those instruments, right? And we can take readings. Free from error, especially as a result of care, and able to give accurate readings. So this is accurate. Of course, accuracy is how would you define accuracy?
Precise.
How precise something is. That's exactly right. So this is some of the guys. So whoever put this is not my PowerPoint. I got it off the internet, but I really liked it. I guess I could take off some of these slides. But this is dealing with probably auto mechanics or people that actually do stuff like rebuild engines and stuff like that. I had a riding lawnmower, and it we had a piston that broke in it, and so we got in, we took it out, we got the model number and everything off the engine. We took it to the parts place. It wasn't the actual piston. It was the rod, the connecting rod that connects the piston to that. And went out there, got the engine, went out there, and put it in there. And as soon as we tried to crank it, it beat up against the top of the head. So the connecting rod that they have wasn't the right one. What we should have done is measured it, but we took for granted the guy. He was pretty smart. And what had happened is the lawnmower before I got involved with this big lawnmower, we had an association out in the neighborhood that I live in, and then we cut our own. We had what we call common land, and we cut our own common land that goes with the association of the housing place that I live in, and so we used to do all this stuff, and we before I started doing that. They had messed up the block on it, and they replaced the block, and they didn't have the exact block, so they put a different block in there than for the motor that's supposed to be in there. And so all the pistons and everything was correct, but they put the same valve cover and everything on the top. So when we looked at the part number, we pulled it off the old valve cover instead of the new valve cover. So the guy gave us the wrong size rods for our pistons. So we loaded up the motor. It was off the lawnmower. We loaded off the motor, and we carried it over to the guy. And Dano, it was his name. He came out there and actually looked at it and realized what had happened. And he gave us the right connector rod. But if we would have measured it, then odds are we wouldn't have had that problem. Luckily, we didn't. We noticed it right off the bat, and we didn't mess up the valves or anything like that. So this is some problems with this is the rod here that we actually replaced. And the problem is that it was a hair too long, because it was a different block than what we thought was in there. So he wrote all over the valve cover what block was actually in there. So after that, we didn't have any problem getting parts for it. So there's just problems we have with people that just don't make precision measurements. So this is what could have happened to us right there. We could have beat the head up by doing that. It's stupid. That's a good sign to carry, right? So the measurement instruments we're going to look at is micrometers. We're going to look at vernier calipers, dial indicators, telescoping gauges, which we don't have, small hole gauges, thickness gauges, and of course we do have straight edges. So inside the kit that we'll be doing with in our lab, we do have, we'll be doing, the lab that we'll be doing will have there's a dial indicator in there. Let me get my pen untangled here. So these we have in that kit that we have, and then we have a straight edge. And then of course it says a thickness gauge, but we usually use one of these to do that. So this is what we call an outside micrometer. The instrument for measuring precise linear measurements of dimensions, such as diameter, thickness, length of solid and body. Of course, it consists of a C-shaped frame that holds the whole thing together, and a movable jaws. We'll look at this. So these guys right here actually move. So this right here is fixed, and then this right here moves. And then on the back, we have a screw operation that when we turn it, we're going to make our measurements by reading the actual dial back here. And we'll look at this. And of course, those that you're looking at is metric. And of course, I have some, we call it the imperial standard now. So this deals with his, feet, yards, and that kind of stuff. Of course, in metric system, we're going to be dealing with millimeters, right, centimeters, millimeters, and that kind of stuff. So this is the basic let-up of imperial and metric. So these are pretty easy to measure. Okay. And then, of course, this would be 1, 2, 3, 4. So these would be, each one of these would count as 0.25. And then these would be units, and this would be what we call subunits. So we'll look at that in a minute. So if I was going to read this, I know this would be, first of all, you need to find out the range. So this would be a 0 to 1 inch. So I'd start off just reading this one. 1, 2, 3, 4. That makes sense? And then this right here would be 0.5. And then since we can't see this line right here, so right now I've got 0.045. And then we come over here and read this one, and it lines up at 9, and that sets that size right there. So that would be how we read that. Does that make sense? Yes, no? The metric, this guy is not quite right. So this right here would be 1s. So this would be 10. This would be 11, 12, 13. This would be 13 point. Since we can see this and it's halfway in the center, this would be 13.5. So I don't know how he got this measurement right here. And then, of course, we would come over here and add 30 to that. So this would be 13.8. So I don't know how he got the 0.1 right there. So his is wrong. This is what we call an inside mic. And they'll give us, this is what we call a depth micrometer. So we use this to measure what? Depth. So this is the outside mic. You should have one of those in there. And then this is an inside mic. We don't have this one. And then this right here would be a depth micrometer. We have one of these, by the way, on our linear, linear veneer too. So we have digital, and of course these are nice because what you can do is just read it off the indicator. But we don't like to use those until you understand how to use one of these, and that gives you a real feel of how to make measurements. So ours are going to be maintenance. And then you have combinations, which you can measure here or measure there. So these are the parts for a outside micrometer. We have what we call the anvil. So the anvil mounts to the top of the C. Then we have the spindle. So this is stationary. Then we have the spindle. So this guy right here is going to move. And then what we want to measure, we're going to put it in here. So what we're measuring is going to be between the anvil and the spindle. Then we'll have what we call the sleeve. This is where your major divisions are going to be at. Then we have a thimble, which is what we're going to turn to cause the anvil to move in and out. And then on the back is what we call a ratchet. So what we do is when we get close to what we're measuring, we'll let go of the thimble and we'll move back to the ratchet. And they call it a ratchet because as soon as it touches, it'll click, and you know that you don't need to go any further. That makes sense? Okay. So, precision instruments, I don't know what this is. Of course, what we don't want to do, we don't want to ever drop these, so be careful. We don't want to run over them. We don't want to over-tighten them. Normally, if you over-tighten them, you'll get them out of calibrate. You don't put them in a vise, right? You don't drop them into chemicals. You don't leave them in a freeze. You should get used to cleaning your tools after you use them, and if you do that, they'll last a lot longer. Even if you work on, you get your own tools every time, especially in greasy environments. Do not let anyone borrow it, because these things cost a lot of money, and do not leave lying around. So, that makes sense? So we've got, I don't know, I need to ask Nancy how much they cost. We can't do it now because we're not certified, but we got some, Starrett is a big guy in precision measurements. If you get into this, you're definitely going to hear them. And we got a big cart like this, but it's all Starrett instruments. And once we get certified, we'll be able to offer that precision measurement certification to y'all. Keep clean, keep calibrated, keep in a storage box, keep locked up, keep away from everyone, keep in practice reading it. So, of course, this is what we do with the outside mic. We're going to use to measure diameters. We can measure some thicknesses. We can measure different things with it. But these are all going to measure, whatever we're going to measure, we're going to put between the anvil and the swivel, right? So this is an example of an outside mic. This is a pretty good size one. And this Craftsman, these were the first ones that we originally got when we started teaching this. And let me bring my camera up. And what we can do with this guy, I know what I'm doing. Good. So this is the Craftsman. Now this is an Imperial mic. This is an Imperial mic. Where's my camera? Okay. There it is. Okay. So this guy right here is 1/4 inches. And then, of course, we got some standards here. So these are standard lengths. This to calibrate the micrometer. So this is a, and y'all might not, I don't know if y'all don't have those, but this is a, I thought it was written on it. Oh, it is. So this is a 3-inch standard. And I just didn't read it. And this right here is this is a 2-inch standard. And of course this right here is a 1-inch. So we can use these to calibrate the mic. We can also use, well, to check how accurate it is for number one, but we can also use it to calibrate the mic. This goes from 0 to 4 inches, but what you do on this mic is you change the anvil out. So right now it is 0 to 1 inch. So I've changed the anvil out on it. So we can change, we got these different anvils over here. So this is the one that I would use to make this thing go from some measurement to 4 inch. I mean, so from 0 to 4. Does that make sense? So this is pretty neat. This is a pretty neat feature that we have where we can come up here and actually do this. But once we change it out, the odds are we'd have to recalibrate. We'd have to recalibrate for it if we change the anvil out. So it's got a calibration tool. You should have one in your box where we can literally put it on the side and then we can turn the mic and calibrate it. So this is Imperial, by the way. The ones that we're going to be doing is metric. So this is a depth gauge. So we use these to measure how deep things are. Just if I didn't know We do these a lot if I've got bolts or something that doesn't go through something, it goes down into something, to make sure we use the right bolts and everything to put that in. This is actually the inside mic. So these would vary in length. So what we're doing is we put one side up against a fixed surface, and then we adjust it until it touches the other side. We don't have we don't use that one, don't use that one. So calibrate unit, identify the scale. Now most of the time when we calibrate it, we just come up here and adjust it. So what we do is normally we just adjust it to 0. Even on this we have these different standards. So what we would do here is we would come in and then we would turn the mic. Let me raise my camera. So what we do, we come over here and we start turning it, and then when it starts getting close to the anvil, my spindle starts getting close to the anvil, I would let it go, and then I would come back here and move over to my ratchet. And then I'd start turning it until it clicks once. And this is where we go. So this guy here is pretty close. I don't know if you can see it or not, but what we're looking at is the 0, the dash on the what they call that, is lined up with the 0 on the thimble. So that means this guy's pretty close to calibrated. If it's not, what I would do is I would come up here and break it loose back here, and then turn it until it got to 0, and then tighten it back down. And we turn it right here. So it's got a tool right here, and that would come in and we would adjust it so it got to 0. Make sense? So that's usually the way I check calibration. If 0 is right, then if it's not right on 0, that means we need to calibrate it. So y'all might look at y'all. Okay. Kevin, we got did you get you one? Yeah. Identify the scale. It's either imperial or it's metric. That's very, very important. Identify the micrometer size. The size would be like 0 to 1 inch. I think the ones that y'all got is a 0 to 1 inch. So if you look on the C, it should be identified what the range is. Now this says 0 to 4 inches, but I can't get 0 to 4 inches without changing out the anvil. Yours are fixed size. You can't change the anvil on that. So right now mine is 0 to 1 inch. And then so up here on the C, you should have what this size is on there. So I think yours says 0 to 1, right? Mine says 0 to 4. But that's only if I put another anvil in there. So identify the range of the mic, read the sleeve, so that's the sleeve, and then we would read the thimble. And then we would add the two together, and this should give us our reading. Are we okay? So every reading, if it's a 0 to 1 inch, then every reading you're going to have is going to be at least in milli, right? Y'all understand that? So yours is in centimeters. Yours is 0 to, what did y'all, 0 to...
What were these kids?
I don't know why. We've had it.
Everything's made each other. I don't know, I'm just saying.
I didn't make it, so I don't know.
That's what I had.
No, y'all are not the person that used it. Somebody just said take it. So we read the first thing we do is we read the sleeve, and then we read the thimble. And it talks about a 4-digit mic, but I haven't ever used one of those. Calibrate it. So first thing we need to do is check for 0, right? Before using any micrometer measure, you need to make sure you check that it's calibrated. And normally all we do is just check to see, you bring it in, you get it close, Don't use the thimble to push it in. When it gets close, you need to let go of the thimble and go back to the ratchet and turn it to it clicks one. And then read your mind. So like we said, this is imperial. So what we do is it don't tell us the size. But this might be, if this is a 0 to 1 inch, then we would start off by reading this. So I'd say it is. This is 0 to 1 inch. I go 1, 2, 3, 4, and then I put 0.4, right? Then what would this be? This would be 0.5, so that would be 0.5. So I put 0.5. Everybody understand that? Okay. And then I move, since I can't see another one of these lines, I would move over to here, and then I'll read this one. And then this will be the third digit. So I'd come over here, it's lined up on the 9, and this would be 0.59, 559 million. So the first thing we do is we read the sleeve, then we read the symbol. And this is true whether it's, and this one, this is 1, 2, 3, 4, 5, so this should be 0.5 millimeters, right? Does that make sense? So over here I would say 10, 11, 12, 13. So I'd write down 13, and then I'd put point, and then I got what? A half one, so that'd be 0.5, and then I would take this one, and then we would add it to there. So this would be a 3.
Why do you have 13 total?
Because it's wrong. So this is wrong. Understand? So whoever put this together did not do this right. 13.1 would have been lined up exactly right here. And this right here would have been on what? 0. So then we add this to this, so it's a little different. So mine's on 30, so this is actually 13.8 millimeters. So this is the one we got. So if you look at your micrometer, which I don't have, it's got what? It's centimeter. I think, no, I'm looking at, what's your scale when you read your C, the outside of your C out there? So 0 to 25 millimeters. So I think yours goes 5, 10, 15, 20, 25, right? And then it's split up like this also. So you got this, 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 this. So it's split up exactly like this. So identify the range, and like I said, that's going to be on the C out here. It's going to identify the range. So that's going to be decided what you go to. Some of them might not start at 1. It might be from 1 to 4. And if it's like from 1 to 4, because this guy right here sticks down further, then it might be where you'd say, understand? 25, so this is what we got, 0 to 25 millimeters. By the way, this is the lock. Sometimes after you make your precision measurement, you want to move it or go somewhere or compare it to something else. Well, the problem is if you barely move this symbol while you're moving it, you could cause it to be wrong. So what we can do is we can lock this thing down. On this one, it's a little different. On the Craftsman that I have, it's a little different. On yours, I believe it's exactly the same way, where I can come in, and once I've got my measurement made, then what we do is we'll come up here, and on this one, you turn this guy here to lock it. So now, it's not locking. Now it should. Now I can force it, but we should do that, right? So this would be after you made your measurement, and you're going to carry the mic with you. And what you need to do is make sure you lock it. So next time you use it, you need to make sure you unlock it. So if you come back here and try to turn this thing, and it won't move, don't force it. Just go make sure it's not locked. Make sure it's not locked. So y'all has a little lock on the side, just like the diagram, right? And guys at home, I don't have the, but y'all get the handle on when y'all come in the next class. So this is imperial. So this right here would be 0.25. So this would be 0, 1. Okay, can y'all see mine? So what does it measure? So first of all, we read the sleeve. Then we read the watt. Then we read the thimble. So what's my measure?
Okay, 2 on 114.
Well, this is not 1, this is 2.5, because notice we got 1, 2, 3, 4. So each one of these is 2.5. So it's going to be 0.2, 5, plus, 2, 3. Thimble turn goes from 0 to 20. Okay. So what's this read? Let's see if we can do this one. So this is metric. But it might not be. So let's see. So this is 0.25. So what would this measure?
That's going to be 0.5.
Yeah, so this would be 16, 17, 18, 19, 20. If there's nothing here.
Is that right?
So we took it.
I was going to say 0.66. But
Yeah, this is so this wasn't right what we did over here. This moves over to right there. So this is the second digit, and then this right here is the third digit. So we come over here and we say 0.2, and then we read this right here. So this would be the second digit. Yeah, that's right. So we should have added it this to the 5, not to the 2. To the 2. And this would be 0.25, right? We did it right, and then so this would be added to this right here. That's what we did. So we're doing the same thing over here. So here we'd say, right, we'd say 0.5, huh? Yeah, there's no doubt about it. It's got to be wrong because we can see this symbol real good. So there's no way in the world it's a 3. Because this right here, can y'all see that? Pretty good. We're looking at the numbers on the thimble. That's a what? That's a what? What's that? A 2. So there's no way in the world that makes that just that much right there makes that wrong. Because we're not even we can't see the 3. The 3 is over here somewhere. Understand? So this right here's got to be wrong. Because just knowing what we know, that this right here is the first digit, and this has got to be wrong. Which would be a 0. So let's see if I can remember. Let's get 0. And then each one of these are what? Each one of these are 0.25. So it's going to be 0.05. So I got myself confused. And then we would come up here and do what? Add 16 to this. So this would be 0.066. So I got myself confused because I was thinking of this being a 1 instead of being actual 0. let's see if we can do this. Okay, so let's see. Major light, zero, space. So what would this one measure? This looks like this is in millimeters. So let's get to one we can see a little better. So what would this be? So we can't see the one. So what would this be? This, and this would be a what? This is the same one. 0.25, 0.255, and then we read this, 16, 0.066. That's the same one. Okay. Okay, so what would this one measure? Oh, this is a 2 to 3 inch mic. So what first thing we're going to do is we're going to start off with 2, and then we're going to put a decimal. Okay. You'll see this. So this is what this is talking about first. Decide the range of the mic. So this is a 2 to 3 inch mic. So what would I do next? 5. And then you're right, because it's lined up on 0. Y'all got that? At home?
No, do that one again.
Well, first of all, we look at the range. So a while ago, it was 0 to 1. This is 2 to 3. So what we do right off the bat is we write down, I'm going to write down, we're going to start from 2. A while ago, we started from 0, right? And then I'm going to put a decimal point. Then I'm going to write down, I know this is 5, right? This would be 5. That's the second digit. Then I would come over here to this. This would be 0.25. But we're past that one, and this is lined up with 0, so that stripe right there, so that'd be another 0.25, right? So that's going to be a what?
If it were larger, if it were 3 point something, it would show a larger 3.
That's how.
It will be, or the it will be on out longer.
What's that?
If it were, you said it's 2 to 3 inch, like what case would it be 3 point?
I've never seen them go in fractions. They've always gone like in 1 inch, 2 inch, 3 inch. I've never seen one that starts out in the middle like this. So what we're saying is that this thing right here would never even close. So even when your thimble started ratcheting, you would have 2 inches between that and the ample. So I would only be able to measure things between 2 and 3 inches. No, this is the name of the instrument. So even if this, huh?
2 to 5, is that millimeters?
I think no. This is imperial. This is in inches. In fact, we should have known that. That's not meters because it's using the inch sign. Understand, Judge Roy? Yes.
Yeah, but it's only 2 inches.
Yeah, but we start with 2 because that's the first number. So if it's got 0 to 1, then we'll start with 0, and then we'll put the fraction right there. Here it says 2 to 3, so we start with 2, and then we put our decimal point right there, and then we read it the same way that we did before. So we can't see the 0, so next we read that number right there, right? And then we come up and do what?
Well, there's 5 millimeters, I guess, or what are those inches? Those aren't inches. So is that 5?
This is not, so this right here would be 2.2. This right here would be 2.3. That right there would be 2.4. This right here would be 2.5. Because we start with what? It's imperial, so all these are in inches. Yeah, so the maximum we would have is the fractions, and we're not doing inches, we're doing, so we're not, yeah, so we're doing, right. So what you said was right.
I was confused about that. Like, well, the 2 or 3, but there, I guess 3 would be 10, like 2.4.
Oh, sorry. Well, we could, it's just that I was starting with point 1. So what this right here, this is your second digit right there. So I was, in my brain, which I was wrong, I was starting with 1 instead of starting with 0. Okay. So I was starting with 1, but this actually starts with 0. Understand? Yeah. Well, they're not, because first of all, these, first of all, it's not millimeters, because number one, this gives us the range. What does that symbol stand for? Okay. So that means this guy's in inches. So if I look at mine and it says 0 to 1 inch or whatever, then that means, so what we're doing for is we're coming over here, and this right here, after the decimal point, this sets the first digit. This sets the first digit, right? Does that make sense? Yes. So I look at this. This is the first digit, so I'd put a 0. Then over here, I'd say this would be 0.2. This would be 0.5, and then I add the third digit to that. That makes sense. And then that's why we came up with 0.066. In my brain, I was seeing this as 1, but it's not. It's what? 0. So this sets the first digit. So over here, let's don't say 2 to 3 inches, and get us confused. Because like I said, I've never seen a micro measure that don't start with 0. So let's come up here and do like we did before, and let's, even though they might be out there, this guy seems to think they are, but like I said, I've never seen one. So let's say this was let's say it was the same as before, 0 to 1 inch. Well, what I would do is this sets, so I start off with a decimal point, and this sets the first digit. So I'd come up here and this sets the first digit. So you're right. So the first digit would be a what? Would be a 0.5, and then that would be a 0.25. And then I'd come up here and measure this. There's another one, so that's going to be, oh, here, yeah, so then another 0.25, I didn't add it, and this is going to be what, 0.55, right? Well, you can't see it because it's right on the line. What we're looking at, if I can't see it, then I'm going to look at this thing right here, and it's lined up with what? 0. So that means that sucker's got to be sitting right on top of that line right there, right? Understand? Because it's lined up with 0. So that would be 0.25. And then what we do, if I could see the line, then that means this guy here is going to be up in here somewhere. If it's up in there somewhere, I can see that line, but since it's on 0, I can't see that. Does that make sense? So you can actually look on your micrometer, and when that 0 lines up, well, here you can barely see it. Let's see if I can bring my camera up. And it's probably there. It's probably just a hair on there, but it should be in the center of the next line. So I don't know if y'all can see it or not, but if I come up here, I'll try to get up close again. See if it'll focus. Been doing a really good job. So if I put it on 0, then I can just barely see that 1. But as soon as I move off of it, then I can see the line. So right here, I can barely see it because it's splitting that real thin line, and then I move it over there, now I can see it. See it on yours? Yes. So what we're saying is the line is there. It's just that his pictures don't show it because all we would see is just one barely little. So this should be splitting that line, and those lines are a lot thinner than this right here. So yeah, if you look real close.
Yeah, I don't see it here and I see it here.
Yeah. So if it's on zero, if this guy right here is on zero, that means it's on top of a line. And you could probably barely see it because it's taking that line and it's splitting right down the middle. So what you do if it's on zero, then you go ahead and add the next unit. Does that make sense? Yeah, so since it's on zero, that means it's got to be sitting right on top of this next line right here. So this would be 0.25. And then it's on zero, so it's got to be sitting on top of that other line, so it'd be another 0.25. So it's good. Huh? Yeah, so this is, if we go from, so we start off and read this digit right here first. So this one starts at 2. So if it starts at 2, the first thing we do is write down 2. And then I put a dot, and then we do the same thing as we did before. I come up here after the dot and put the 5. And then my next one sets the next 2 digits, right? So this would be 0.025 is the way I should be writing it, plus 0.025, which would give us what? 0.05. So that would be this measurement right here. Oh, he gave us that one. So what would this be? So I can barely see the 8, but I know it's 2 past that. So I come over here, right? It's past this. So this would be what? 0.8. Got 2. 0.02. Yeah, because it's past, so, wait a second. Yeah, it's because it's past 0. Understand that? So if it's past 0, then it's gone past the next line. It's got to be past the next line. It's just that on this diagram, it just doesn't show up there. 0.802. So what we're doing on this line right here, we're looking to see if it's past 0. If it's on 0, then it's right on top of it. If it's past it, then y'all understand? Yes or no? So this one's going to start off with 1 point. So what would this be? Would this be? Huh? Somebody at home said something. Yeah, 6, 4, 5. So let's see, this would be a 0.25. So that's going to be, right, that's not there. So it's 1, 6. So we see the 6, 2, 5. Right? 1.645. I didn't say you did.
Would it not be 1.650 plus 0.03? Is that little nine?
What little line?
To the right of it, 6.25, that little roughly. Yeah, it's on 0.5, right? on 6.5.
That's 2.5. This is 6 point, this is 6, right? 6. Start off with 1, because that's where you start at. That would be a 6. Then that would be a 2.5. And then this is a 20, so it add 20 to that. That's 1.645.
Well, I'll talk about that little space.
This space right here?
Yeah.
Well, that's what this guy right here is measuring.
Oh, okay.
That's what this guy's measuring. It's actually measuring this. So if we look at this, and when it goes around, so each one of these is 2.5, right? It's actually 0.025. Well, look, this comes 15, 14. This would be 20, 21, 22, 23, 24, 25, and it rolls down to 0. So this is actually measuring that what? That 0, 2, 5. So that makes sense.
Is that why you're saying if it's above the 0, count that not?
Yeah, but this is lined up exactly on the 20.
Okay, fine.
Yeah. So we would count this one. So this would be 1 because it's 1 inch mic. Then the next digit is set by this, right? Then the next digit would be set by this. So that would be 2.5. And then we would come up here and add 20. So we can't add 25, right? You understand? So we'd come up here and add the 20 to it. And that's going to be 1.645. Make sense? 1.645. Metric. This is a little different. Notice the thermal numbers are higher because they're moving in metric. I've never seen a 4-digit. So this would be what? So this would be, this is millimeters, yeah. So this is 0 to 25 millimeters.
Okay. 1, 10, 1, 0. Is that right?
Yeah, because it's 0 to 25 millimeters. So this would be in millimeters, right? Oh no, let's look at this. Okay, so that was wrong. So this would be, all right. And then this right here would be, over here we got 1, 2, 3, 4, 5. So this would be 0.2, 10.2, right? And this right here would be 5, 10.25. So follow me so far? Because this is 1, 2, 3, 4, 5. This is in the center, so this has got to be 1.5. This has got 2.5. This has got to be 3.5. This has got to be 4.5. That makes sense? So I come over here and I see, I go 1, 2.5. Makes sense? I can't see y'all if y'all raising your hands. Y'all got to speak up. I hear y'all. Okay. And then I would come over here. I know this is not on top of this one, which would be the next thing to occur. It's not on that one, so I'll move over to my thimble. So my thimble is lined up right here. So this is going to be 15, 16, 17, 18, 19, right? 10 point, what? I think we had the 19 there. Let's make sure. That is. So this would line up here, guys. I don't have it lined up right.
First number is
10.
1, 2, 12. And 12 point. What was the answer we would say?
10, 11, yeah, you're right. I'm sorry. Thank you. Oh, I was looking at that during the conversation. What does the teacher say? I was just seeing if you're paying attention. 12. Okay. And then this right here would be a what? 12.25, and then this right here would be a 19. So it should be 12.269, 10.269.
No.
No, this is sorry. Yeah, you're right. Yeah. So 12, I'm getting it more accurate than it is. So 12, then this would be a what? 0.5, and then we'd come up and add what? 19. So 12.69. Got it? Do we need to go back? Yeah, I know, sorry. I saw that big number up there. So thanks for bringing that up. So this would be 10, 11, 12. So I write down the 12. I put a decimal point. This right here is going to be 0.5, right? And then 19. I'm going to add 19 to this. So that's 12.69 millimeters.
Take out that 5, right? And then just like, okay, like you said on the micrometer, so you know what, like the spacing on the hand, you don't add it.
I don't know what you mean. This is 0.5, and then this is not on 0. So that means I'm somewhere in between. I'm somewhere in between here. Well, that's what this is measuring. This is measuring how far I am between here. Understand? So what I would do is I come over here, and this gives me 0.5, but I'm not all the way over to I'm not all the way over to the 11. So that would be the next mark that I would see down here. Okay, since I'm not here and this is not on 0, so if this was on 0, that means it's on one of these lines. Since it's not on 0, this is telling me I'm 19 between 0.5. I'm setting at 19 between there, right? You understand what we're saying? So I'm going to say 12. We can see that. I can see that guy, 0.5, but we can't see this one. So we know we're somewhere in between 0.5 and then something over here before I get to 11. So that's when we move over here to the thimble and we look and see what's lined up. Now, if it's in between, guys, you just got to guesstimate at it. So right here, it's right on the line, so I know this is 19. So that means 19. So 12.69. So I'm almost 70% to the other side. I'm over halfway. That makes sense? Well, the problem is this is a line right here. And this is a line right here. This is a line right here. So this would be 1. This would be 1.5. Right? You understand? This would be 2. Well, the problem is I'm not to 2 yet. I'm in here somewhere. So this guy right here is measuring in between. It's measuring between the dash, the lines. So if I'm on one of these lines, then this symbol right here would be sitting right on, it'd be on 0. This guy right here would be on 0, which means I'm right on top of one of those lines. So we're trying to figure out where I'm at. So I'll bring this up here because the way it's split up. So if I'm between this line, so I'm not here, and I passed this. So that's when we read this. We read this right here. I see that. I can see that plain as day, right? You understand? But it has not reached this line over here, which we cannot see. So over here somewhere, there's another line that comes down here, which would be what? 10, 11, this would be 10, this would be 11, 12, this would be 13. I can't see 13. So this thimble, once I get past that line, that's when I write down the 0.25. I'm sorry, yeah, the 0.5, because that's 0.5. So 12.5. This is this line right here. But it's not on that line, it's somewhere in between that line. It's not on this line, and it hadn't reached this line over here yet. So what the thimble is reading, it's reading the space in between here, between the major lines. So that's when I come over here to my thimble and I see it sitting right on top of what? It's sitting right on top of 19. So it's not 5, it's not 5, right? It's not 5 and it's not 13. So then we would take the 19 and we would add it right here and we come up with 12.69. So this is 0.69. These are in millimeters, so these would be micrometers between here and there, right? You understand that? Before it actually reaches it. So if I kept moving this around, moving the rest of it, there's going to be 50 increments on this thing. Well, it's not going to see, it's going to go to 49 and then it's going to roll back around to 0, because if I kept moving it and it hit 0, it meant it was right on top of 13. And then if it's not on 13, if this thing's not on 0, then what this guy right here is doing, it's measuring the space between these lines right here. So that's what the thimble does, and that's what it does on the imperial mic too. So if this guy right here, if the thimble is sitting on the top of 0, that means it's right on top of one of these major lines. If it's not on one of these major lines, then this guy right here could be what? It could be anything between, so if this right here is, if this right here was 11.5, right, you understand? And then this right here, I'm sorry, if this one right here is 10.5, and this right here is 11, then if this thing is not on 0, then it's somewhere in between here. And that's what our thimble is showing. So we take this number, we know it's not to 11, so it's still sitting down here on 10, but it's going to be something, right? You understand what we're saying. So that's why we take this and add it to that to get the actual space. I don't know how else to explain it. I mean, so if I was looking at a ruler, and it's set up in quarter inches, and then I was to come up here and it's somewhere in the center, then I know it's not going to be this one. I know it's going to be that one. It's going to be somewhere in the center, right? You understand? So that would be like me having 1 inch and 2 inches, and this is 1 inch, and this is 2 inches, and it's not on this line. I know it's past that line, but it's not up to this line. So then I start coming down here and reading my ruler, right? You understand? It might be 30 seconds, it might be quarters, it might be whatever, and that's where we get the last measurement. So what we're doing, instead of having all these little increments between these, I don't know if y'all seen a ruler that's set up in 30 seconds, but those lines are almost on top of each other. Well, instead of us having to measure that, all we do is look at our next one. If it's not on 0, then we add this to that one, and that gives us the space in between the two. So what would this one be? So I'm going to start off with what? 20. No, I'm sorry. I'm going to start off with what? 21, 22, 23. 23.5.
49. 449.
Exactly. 0.99. Yeah, this thing is almost around 23, Rick. $23.99. So that's inside mics. I mean, that's outside mics, and this is imperial. So these things are going to be set up in inches. And then this is metric, which is what you have. So the micrometer inside that kit there is metric. I think the shims though, I think they're set up in inches. I think. Okay, so this is what time is it? So this is a telescoping gauge. And so these are spring loaded. So what you do is so this is what we can measure the inside of just about any gap that we have to measure. And they come in different sizes. So normally what we do is we put this thing in, we touch it, we bring it out, and then we usually use like an outside mic to actually come in and measure this. No. Like I said, the only thing we have in our kit, what did I tell y'all had? We have a outside micrometer. We have a linear veneer, and we have 2 rulers, metal rulers. So outside mic, 0 to 1 inch. These are small hole gauges, by the way. We don't have any of those. These are what we call divider calipers. We can use these to measure the inside diameter, but what we do on these is we come up here and we actually measure the inside with it, and then we lock it down. So you can see it's got a lock on it right here, so we can lock it down. And then what we usually do is we take that out, and then we use an outside mic to measure that. So we're basically using 2 cheaper instruments to measure the inside diameter or something, or the inside, not only diameter. This could be measuring any inside that a mic can't answer. You'll see that? Does that make sense? Yeah. So what we'd do is no matter what it was, so it could be a square, and we can't, and then we got big old sides on here. We can't get our mic into these. So what we'd do is we'd use the divider, and we would come up here and we'd spread it out till it touched the side, and then we would take that out and measure that with our mic.
But now, how you gonna get that out without tightening it back down?
I don't know what you mean. It's just touching the sides. It's not clamped in there. That makes sense? So it would be just like me coming up here and taking this thing. And if I don't tighten it down, if I just come up here and let it touch the sides, so on the mic, so this is 1 inch. So we're not going to clamp this down. So if I come in here and I bring this up to make this measurement, we're not going to clamp it down. We're just going to turn it till it clicks. Then I can come up here and lock this down, and then I can pull that sucker right out of there. Because you're not clamping it in there. Because as soon as you clamp it in there, then you're pressing and you're changing the size, right? You understand? So yeah, that's what we're doing with these. We're not tightening these things. We're just pushing them in there. We're adjusting them out till it does what? Till it touches the sides, not clamp it in there. We're not going to let it go and let it hang there, right? And we should be able to just do what? Pull it out. That makes sense now? And then we would do what? Then we would come in and we would make we'd make the measurement with our micrometer if we want it to be extremely accurate. If we don't want it to be extremely accurate, we might just use a ruler or something to measure the caliper. Standard, I always have problems. Linear calipers, I always have problems saying that. These guys have 3 things available to us. We can measure the outside of something, we can measure the inside, and then we can also measure the depth. So this is a depth gauge down here. So this guy here has several functions. You should have one of these in your kit. Ours is a combination of a dial and the actual manual. So we'll read this, we'll read the major units, and then we'll use the dial to get the minor units. There you go. It's stuck in the phone. Yeah, there you go. Instruments for making very accurate linear or angular measurements introduced in, we don't need to know that. A main scale similar to that of a ruler and a special graduated scale, the vernier, that slides parallel to the main scale and enables reading to be made to a fraction of a division on the main scale. So if you look right here, you should see where this actually comes in line. So this guy right here is fixed, it don't move. And then you should have a little screw down here that you can turn, and it should have a lock, so once you make your measurements, you should be able to lock it down. And so this is what we can measure: outside diameters, inside diameters, we can measure thickness, and we can measure depth. So this is a very versatile tool. So of course we know what the divider is. So am I going backwards? So there we go. So this is what we have. So this is what we're going to be using to measure the outside of things. This over here we'll use to measure the inside of the things. And on the very bottom, when you slide it out, you'll see there's a rod that comes out of that right here that we can use to measure depth. So this is a really versatile tool. Who makes that one? We got how much? We don't. All the stuff in our calibration, our precision measurements, by the way, is stereo, but we'd have to go over to the machine shop for that. Okay, guys, let's go ahead and take a 10-minute break just to get up and move around a little bit. So that'll put us back at what, 2:46. Take that. So what you move it with this little roller right here. We move it up so it touches, and we don't want to use a bunch of pressure. We check to see if it's zero. This is the vernier scale right here, by the way. And then I can break it loose and just come up and adjust it to zero. So it's a lot easier to calibrate than with a gel. Then if I'm going to measure something on the outside, then whatever we're going to measure, we would come in here and we just put it into the teeth. And we just come up here and close it. We don't want to tie it, we just want it to touch, right? This is where we can lock it down, so we can lock down the scale so it don't move if I want to take my part out. We come up here and we read this, so this is in, let me get my scale, make sure I got this up. This is in millimeters, so these are centimeters. Each one of these dots is a millimeter. So there's 10 millimeters inside a centimeter. So what we usually do is we usually read it in centimeters. So I'd say this would be 20. Then I'd say 1, 2, 3, 4. Can y'all see that? And then I would come up here and I would line this up right here. So this would be 25. So this would be, sorry, 25. We can't see the other one. 0.4 millimeters. I'm not 4 yet. I'm sorry. It's not 4 yet. Go ahead. 2 centimeters are 20 millimeters. So every time it's got a 1, what we would do is we'd say 1. Instead of saying 1 centimeter, we'd say 10 millimeters. Okay, does that make sense? Okay. And then what I'm reading is I will come up here, let me loosen it up. I'm going to come up here and check my zero again. Okay, so I'm off a hair. what is that? Lock it down, so that's why we calibrate it. Then what we measure, so this is supposed to be exactly 1 inch. This is my 1 inch standard. I'm going to come up here and do it until it touches. Okay, right? And then I'll lock it down. And then I would measure. So if I look at this, I get it to focus. So that would be 20, 21, 22, 23, 24, 25, and it's past 25. It's between 25 and 26. So if this was on zeros, if it was on one of these zeros, whether it's on the top one or the bottom one, that means it's right on top of a line. So it's not on zero. So this right here is not on zero. It's up here on 4. So I'd come up here and I'd say 25.4 millimeters. I'm not understanding, Kevin. I'm reading mine in millimeters. So if I read it in millimeters, then I just take the 1, and instead of calling it 1, I'll call it 10. Understand? So I could say it's 2.54, it's 2.54 centimeters, or it's 25.4 millimeters. Both of those would be correct. So that's good. So you can see the 2, you can see it's over the 5, but this is not sitting on 0, so I know it's not on 6. So that'd be 25.4 centimeters. Or 2.54 centimeters. Did I say it right? This is 25.4 millimeters, or 2.54 centimeters. Which one of those would be correct? Both of them. Right. So it depends on what you're trying to get your answers on. So this guy right here is really easy to read. I mean, and of course, and that's what I had up here, by the way. So I was going to say, okay, of course I do this, but there's all type of conversion up on the internet. So I wanted to come up here and I wanted to convert 1 inch to millimeters. What is it? 25.4. And what's my measurement? 25.4. Yeah. So whether you say 2.54 centimeters or whether you say 25 millimeters, that's exactly the same. And I don't have enough standards, by the way. This guy right here is a 3-inch standard. So if it's a 3-inch standard, we should measure, I can multiply that by 3, but I'm going to let this do it for me. 76.2. So I'll come up here and get my linear. Bring up my camera. Okay. So these are the ones we're going to be using. So 0, check 0. Okay. Then I'm going to come up here and take my 3-inch standard and slot down. Yeah. My 3-inch standard, I'm going to come up here, just come up here and let it touch, right? Okay. And I'm measuring 51.1 millimeters. Oh, 76. This is, let's see. Oh, this is a 2-inch. Duh. So 2 inch. 51.8. Mine's not measuring 0.8. Oh yeah, it is. I'm going the wrong way, guys. Sorry. Mine's measuring about 51, a little over 51.9. So what I was doing, so let me bring up my camera. Let me show you my little mistake. So it swings this way. So I was reading it this way when it swings this way. So this would be 51, mine's measuring 2-inch standard. I need to get it somewhere where it's not at an angle. Okay, so this way it's measured 51.8, and then this would be the fraction right here, 4 of them each smaller. Each one would be worth 0.25, right? So I think 51.875. Now inside, I don't have anything. I guess I could come in here and measure this. So what I would do on this one is I would come over here and move it until it touches, and then I could come up here and measure this. So this right here would be 10, 11, 12, 13, 14.1. Each one of those would be 0.25, 0.1, 5, yeah. And then the depth gauge, we'd come up here and put it on that, and then we'd do the same thing. We'd run it down to it stops, and then we read the main scale first. If this is on 0, if this comes up here and lands up on a 0, then it's right on top of a line, right? You understand that? If it comes over here, you should be able to barely see the line, but if this is not on 0, it means it's over a line. So this guy is, to me, is a little easier to read than the micrometer. Now, which one's the most accurate? I imagine the micrometer would be more accurate. We can get down to the microns and on that, but these right here are accurate for a lot of different things. And of course, the last thing we'll look at is rulers. We went to when we were in, there was a consortium of colleges called CARCAM. We'd say, I can't remember what it stands, Nancy would know. But we were a member of that, and we had meetings all the time, and we would have industry people come in that was actually members of CARCAM, like Toyota and Mercedes, and they would come in and talk about their new people coming in. And one of the things, the biggest things they brought up is getting people in there that didn't know how to read a ruler. So, do y'all know how to read a ruler? Oh, good. That's what that says. That says TCP. Teach these kids how to read rulers. So, we got 2 rulers in here. Oh, by the way, we got a dial indicator. We probably need to come back and look at that. I don't think we got any measurements that we can make. A dial indicator, basically, you should have one of these in there. We use these to check the height of things. We use these to check the roundness of something. So if we're aligning a shaft on a motor and we want it to be perfectly aligned, then we can touch it. If this thing moves when that thing, it means that shaft is what? It's out of line. So we use these guys here. And we do have a set of those in there, but I don't think we have any labs on that. Feeler gauges, these are set at certain widths, precise widths, where instead of making measurements, if we need to set something a certain size, we can use these besides micrometers or other measuring devices. We used to use these a lot on old. In fact, you might still need to do that. if you replace the spark plugs on your car, uh, the the gap between here has to be very precise. If you get it too close, they're going to pit and weld together. If you get them too far apart, you're not going to get the right arc, and you're not going to get the fuel consumption.
What is the standard for that?
0.35 is what we used to, everything used to be almost 0.35, but you need to look at the manual on your book, or you don't even have to have manuals anymore. You can just probably get on the internet and say what should be the spark, the gap on a 1918, and give it the model number, and I guarantee you somebody's going to pop that up. Another thing that we used to do before we had electronic ignition is we had what we called it a distributor, so it would have 8 of these things if it was a cylinder. And then basically while your engine would turn, it would just come over here and create a circuit between each one of these, and then it would fire your spark plugs. But what they did to actually fire the spark plugs is they had a set of what we call points that was right on the cam gear. And then when the cam would hit, and setting the gap on those points was very critical too, because this would actually determine how long the spark plug actually fires. Of course, all this is done now electronically, so we used to have to time the car, but this would still be very critical to setting the spark gap. And of course, what you do is you buy a set of filler gauges, and of course, this looks like these are in metric units. And basically, you just slide it in the gap until you don't crimp them down on it. You just bend it until it does what? Until it makes the right gap. So these filler gauges, these are set up at precise sizes. And all we do is we use these to set the gap between things. So if I need to have a certain space in there, then I would come in here and then it just touches. You need to be able to slide them in and out. You don't want it to grab. Imperial, these are all so imperial is the term they use for what we use over here in the U.S., which is the inches, feet, yards, miles, which is weird. So, we're used to that, but with the metric system, everything runs in tens. The imperial system, everything runs in to the size of a king's foot, right? You understand that? So we deal with inches. How many inches in a foot? 12, right? How many feet in a yard? 3.
Why do they do that?
Well, they just said it. They did it. Basically, it was set up by English people, and they technically did it by the length of people's hands.
Really?
Yeah. So they said.
Other people wouldn't be able to copy the technology as quick.
But they knew they had to have a form of measurement because it was very, very important, because when you build buildings and stuff like that, you need to have a way to measure, So like in the Bible, they use cubic. I don't know what it is, but you can look that up, They didn't say cubic feet, they said cubits, So that was a length of measurement. Well, when they came out with the metric system, we had the imperial system of I need to go back and see how they came up with that. They said that just don't make any sense. You got 12 inches in a foot. You got 3 feet, you got 36 inches in a yard. You got 5,780 feet in a mile. So they said, why don't we just make everything move in tens? So, originally they tried to, y'all don't remember this, but originally they tried to adopt us over to the metric system. So we'd go out and buy cars, and it would have 2 dials on your speedometer. It would have miles per hour, and it would have kilometers. You might still run into those. And all these mile markers up and down the interstate, they had 2. They had one for miles, and they had one for kilometers. All the signs for distances, they would be in miles and kilometers. And what their plan was that once you got used to the metric system, all the miles would disappear, and we would move over to the metric system. But guys, over here in this USA of America, we're very stubborn people, aren't we? So who won that battle? We did, right? So So we're about, over here, we're probably, I think there's only three major companies or two major companies that still countries that still use the imperial measurement. So even England don't use this anymore. so, but we're stubborn. So anyway, so over here they call it the English system. Some people call it the U.S. system. Some people call it the imperial system. So this system right here, this means inches, feet, miles. That's what that means. And then we have the metric system. So this is what it's the name that's come out. So this is filler gauges. So here they're setting the gap on the rings. So of course this is these filler gauges are a little different for spark plugs. Basically, they have a tool on them that you can grab it and increase the length. If they're too far apart, you just tap them against something. If it's too wide, you can stick that thing in right in here and bend them up. And then it's got the sizes on here. So, oh yeah, they're in there because that's still important. Even though your timing, so used to your timing was set by rotating your distributor cap, and you'd have to get what we call a strobe light, a tack gauge. And what you would do is you'd put it on the number one spark plug and you'd point it down and there was a thing on the side of your, coming out of the front of your engine. And you would fire it and it would blink and it would light up a number. You could set up what we call the timing of the engine. But all that's done electronically now. There's still one thing that's not done electronically. And that's setting the gaps on the spark plug. So normally, if you go out and buy them for your car, the gap is probably set wrong. But if you accidentally drop one, then what's going to happen? The gap's going to set wrong. So having one of these things are not very expensive. You want to change the spark plugs on your car if you can. You know, a lot of these people, they'll mount these engines where you can't get to the spark plug. Unless you have all kinds of special tools and angles. Yeah. So, straight edge. So this is what we're talking about, straight edges. No, there's nothing on here. So, what we'll have to do is we'll just look at the straight edge. Is that in metric? Do y'all, can I see the straight edge now? We got two. Edges here that we have. So this is what we call a machinist straight edge. These guys are laid off in, y'all fixing to bring it up. So this is laid off in millimeters, and 0.5 millimeters. And if you feel it, so one of the things we have, I got some plastic rulers, and the information was printed on it. And over the years, what has happened, it actually wears off. So I got a pill box for my medicine, and all that's wears off. But these are actually indented. So that means this right here, you can rub on them and rub on them and rub on them, but you're not going to ever wear off the numbers on that. Because I can actually feel them on my fingernails. So they actually groove these. They groove these and actually put the paint inside of them. You know here? And of course this is the same way. So these are all engraved. This is set off in inches. And then up here it's got centimeters. Of course these it depends. And of course what's on your plastic or your wood rulers, then eventually what happens is it wears out on one end and then it's not accurate anymore. And so sometimes you actually have to count one as 0 and measure from that and subtract that. We don't have that problem here. This is centimeters and millimeters. So remember, for every centimeter, it's 10 millimeters. So whichever one you measure would be preferable to you or whatever your company wants you to measure. So this would be 300 millimeters or 30 centimeters. Okay. And then down here, of course, we got inches. And this would be a foot. And you can see they don't line up. So there are some that come close to lining up, but Of course, they don't. So it depends. This right here is in centimeters. I'm sorry, this right here is in millimeters. So it says 10. So 10 millimeters would be 1 centimeter, right? You understand that? So what's nice about the metric system, everything moves in what? 10. So I really wish that we would go, and the problem that we have, guys, is that where you're at now is that we have a lot of companies that are hiring our students that are not based in the U.S. Their main base. They got plants over here, but their main base is in Germany, right? And so when you go into those plants, they're not going to use the imperial system. They're going to use what? The whole plant is going to be set up in what? The metric system. So that's a system you need to get used to. And you might not. So if somebody tells you 12 inches, you basically know how long 12 inches is in your head, because we've been dealing with that for so long. If somebody says 30 centimeters, you're going to say, well, so even though I've been dealing with centimeters, but I haven't been dealing with the metric system all my life. So we're going to make some measurements. So we're going to have a lab, and what we're going to do, we're fixing to break. We're fixing to let the group one bow out. But what we're fixing to do is, what we're going to do Tuesday is we're going to bring both groups are coming in Tuesday and Thursday. And what we're going to do is we're going to take tests. We're going to take test 3. Well, what we're going to do is we're going to split the class. Okay. So what's going to happen is that the first group will come in and they will do the test 3. Half the group will do the test. Half the group will do the lab. And then at midpoint, what will we do? We'll change. And then the other half of the group, so group 1 will start off by taking the test, and group 2 will do the lab. That's okay. We can swap that around. And then on the final Thursday, we'll just do the final so everybody can come in for the final in the morning.
In the morning?
Yeah, the final start at 9. Not standard start time.
On Thursday, we have to get that.
No, I'm sorry. Wrong class. 1. Yeah. So not normal time, guys. I'm thinking about my other class. So yeah, 1 o'clock. So Tuesday, everybody comes in at what? 1 o'clock, and we'll split the test. Let's don't do it that way. Let me tell you why. Because we need to go over the test. So what we'll do is we'll do it opposite. So what we'll do is half the group will take the test, then they'll go home, and the other half will do the lab, and we'll do the same thing on the final. You understand what we're saying? And that way we'll take the test at the start of class, we'll go over the test, and then half the class can go home. And then we'll do the same thing on the final. So the final, right, does the lab, and then on the final we swap groups. How's that sound?
Tuesday, do you want Tuesday's group to stay and do the lab?
Yes. So Tuesday's group, y'all be here the whole class, if y'all can hear me. So what y'all do is we'll come in and we'll give the test at the start of class, which is 1 o'clock. Then when we're through with the final, then you'll stay and do the lab, okay, on precision measurement. And then on the final day, both of y'all come in and take the final, right? And group 1 will be able to go home after the final, and group 2 will stay and do the lab on precision measurement. Because I just realized we've only got 4 of these kids anyway, so y'all couldn't all do the lab at the same time anyway. Does that make sense? Home group? Are y'all out there?
Yeah, it makes sense, Rich.
Yeah,
That's cool.
I'll post it on the announcement. I'll post an announcement and make sure we do that. So when everybody comes in on Tuesday, everybody will come in at 1 o'clock. All right? Group one, y'all got
Gotcha.
any questions, group one?